I don't get the echo. You can still hear me, but I don't get the reverberation. All right, so I'm going to talk today about some of our work on recognizing dialogue structure in online forums. This is some work that I've been doing just since I went to Santa Cruz. I wasn't doing work in this area before, and I have collaborators at Santa Cruz, Anand in linguistics, Judy Foxtree in psychology, and Steve Whitaker in psychology, and then I have a bunch of PhD students, too many, and we've had funding from different sources, some from IARPA, some from a subcontract from Naval Postgraduate School, which I wasn't supposed to know the real source, and then most recently from NSF. So we're kind of ramping up more in this area. We've had little bits of funding, and we just got this medium NSF, and so there's a lot of work to do, and I'm going to kind of talk about our data and some of the stuff we've done so far. So, as I'm probably sure all of you are aware, there's lots and lots of interesting language data out there on the web. And a couple years ago, we put together a collection of data that we call the Internet Argument Corpus, and we had an LREC paper. We released the data, so I'm going to start off the first part of the talk. I'm going to tell you about our corpus, which you can download, and the annotations that we have for it before I start talking about some of the work that we've done on. And what I would like to say is that I consider this kind of data a really rich resource for research on dialogue, both for practical and for theoretical reasons. And as somebody who's been working on dialogue for longer than I would care to admit, it's pretty exciting to be able to have access now these days to this kind of data. One of the things I think is really interesting about it is that the conversations are about any topic that you can imagine. So the conversations, they range from, this is one of our sources that we've scraped, they range from these very playful conversations like ninjas versus pirates, Star Wars versus Lord of the Rings, Superman versus Batman, all those cats versus dogs, all those kinds of fun topics where people are clearly just entertaining themselves by being on these forums, to technical discussions like benefits of Firefox versus IE, which I think is a bit of an outdated discussion now, but yeah, your mileage may vary. And then some, hot kind of political and social topics where people are kind of deeply committed about these issues and arguing about them. So that's one of the first things that I like about this data. Also, there's lots of different places where you can get this kind of data from, and all the different sites, they offer different kinds of affordances and different formulations of the dialogue structure. So what I have up there is three of the sites that we've scraped: Convince Me, For Forums, and Create Debate, and they all offer something kind of slightly different in terms of the affordances that they give to people, and the affordances of the site actually shape the dialogues that you get in a kind of interesting way, in my opinion. And it's a very large amount of data. In particular, though, what a lot of people have wanted to work on in this data is stance classification, because some of these sites come pre-classified for stance. And one of the other things that we're interested in is, you have this very tree-like reply structure, which isn't exactly like regular dialogue. So you might have cases where you only have these reply links, you don't have any stance, you don't have any labels on the reply links, whether they're agrees or disagrees. And then you have these other ones like Convince Me, where the stance is self-labeled, where somebody sets up a discussion and they put two sides and people have to post on a side. In the case of Convince Me, you have rebuttal links where you can say that you're rebutting somebody else's post. You can explicitly mark a disagreement, but you can't mark an agreement. You can't support somebody else's post or question somebody else's post. So you end up with this kind of odd graph structure where you might have chains of rebuttal links, and then you have a lot of, if you think about it as a graph, you have a lot of isolated posts. And what you end up with is some of the posts have a monologic dialogue structure because they're kind of produced in this isolated environment and they're not a rebuttal, and other posts are very kind of strongly dialogic. So there's all these differences across the data. Another thing is that 4Forums offers this facility to do quotes and responses, and we're very interested in that because our hypothesis was that you have these varying lengths of posts. If somebody goes to the trouble to pick out a subpart of somebody else's post and quote it, that you actually get these kind of a markup from the user's behavior of marking out that quote and then posting it down, and then you get these very kind of targeted reply links. So that gives a different, kind of completely different layer of dialogue structure. And one of the things I've been most interested in is how informal and highly social, emotional the language is. I don't know, can you read that? No? Okay, well I have some other examples that are kind of formatted bigger, but over here on my big labels, so we have this annotated corpus where we release these mechanical Turk annotation task labels, and we have labels for things like this, like whether the person was highly emotional, whether they were being factual in their response, whether somebody was being sarcastic, whether it's a rhetorical question, whether they were being insulting. So there's all these different categories of kind of social emotional language going on that you might think of as a kind of subjectivity. I think Jan might disagree with me as to whether this is a kind of subjectivity or not, but they certainly are displaying somebody's internal mental attitude towards another person. So we have these annotations, and I'll show you later that they actually seem to have some interesting properties besides providing an opportunity to do research on classification just for their individual categories. I'll show you later that if we use these human annotations as an input to other problems, they provide a human top line for getting better performance on some of these other problems. And it's interesting that they actually improve performance, say, on disagreement detection or sarcasm detection. So these are the annotations that we make available right now with our corpus, the Internet Argument Corpus. We took 10,000 quote response pairs and 20,000 post 1, post 2, post 3 triples. And we selected these to have a strong bias towards posts with turn initial discourse cues because several of us were interested in the function of discourse cues. So about half the posts have some kind of discourse initial cue. And then we had them labeled for whether the post and its child post, whether there's agreement or disagreement, whether the respondent is being sarcastic, whether they're being nice or nasty on a scale of -5 to 5, whether they're attacking or insulting, and whether they're being factual or emotional. So we have all these different labels, and you can then bin these things in different ways and use these for kind of classification problems. So here's an example of one. Say the topic is healthcare, and we have a quote and a response. You just have a pair. You wouldn't necessarily have a whole dialogue. Might not have been annotated because we pulled out pairs. And then for that same exact quote response pair, you would get all those different annotations that you could use. Any questions so far? Okay, so why do I think that this data is so interesting, and why am I interested in this problem? First of all, computational models of dialogue have never ever, as I said, had access to this kind of massive amount of data. There's all these different topics, all these different styles of language. You have this massive amount of data. The language of social media, especially these online forums, they seem to have very unique properties. It's the kind of stuff that you might have had to take a recorder into a bar in order to collect this kind of data in the past and have it transcribed. So it's very social, it's very personal language, and as I said, with those socio-emotional dialogue categories, there's lots and lots of stuff in there that people have never been able to study before because they have never had enough examples. So when we first collected this, for example, even just for the keywords, Jeannie Foxtree, who's my collaborator in psychology, who works on spontaneous dialogue, was saying, gosh, I've never had 700 examples of actually before, It's just like really exciting to have that, that kind of data to work on a particular problem. So there's many open research problems in this data because these kind of data resources haven't been available. On our NSF grant, we're continually adding in more data and additional annotations, and as well as like pre-parsing the data and putting parsers in the database. And so watch this website review the data. It's always, constantly being updated. So what I'm going to talk about in terms of our technical work is work we've done on stance recognition, on disagreement detection, and on sarcasm so far. And these are the papers that we have. So does everybody know what stance classification is? So this is like teaching my intro to computer science class, which is a gen ed class that some people have to take for quantitative credit. And it's in a big, so half the people will go on to become computer science majors, and the other half are just trying to get that quantitative credit and get out. And what I did the first year is I have a big class like this. It's full, everybody's like on their phones and laptops and stuff. So the second year I have clickers, right? And I'm asking a clicker question every 5 minutes. And your grade for the course depends on your clicker question. So I'm really tempted in this context, to say, where are you guys, where are your clickers? I can see that you're on your laptops, you're doing other stuff. And this room must hold 200 people, right? Yeah. Okay. So now we're going to talk about stance classification. So the problem is, given an online discussion about some contentious issue, what we want to do is determine each participant's stance. And we use the definition of stance from Somasundran and Weeby's work, which is stance in the overall position held by a person towards an object, idea, or position. Most of the times in our cases, it's a position on a political or social debate, like being pro or con for something like the death penalty. And there's quite a lot of related work, people looking at stance classification, but as I pointed out, a lot of these data sources have very, very different properties. So the data that's most similar to ours is the work of Somasundran and Weeby in the 2010 paper, which is a short paper right at the end of Swapna's thesis work. And it has that data. In fact, we have some overlap in that we've used some of the same data. Some of these other data sources, like a lot of work has been done on the Thomas, Pang, and Lee on the convoke corpus, and it's very, very different than our data. It's congressional speeches. It's not highly linked data. There's all the speeches are very long, and when people have done work on collective classification in this context, a lot of times, like the work of Burfoot and Al, what they do is they concatenate all the speeches of a particular congressperson and they treat that as a single item. Whereas most of the time what we're doing is we're working with those little tiny snippets of posts that are context dependent and can't stand alone. So we have a very different problem with a very different baseline than a lot of these other problems that have been done for stance classification. Like I said, our data is most similar to the Somasundran and Weeby ideological stances data. And this particular study I'm going to talk about is based on Convince Me data, which, as I said, has this kind of weird property where some of it's highly dialogic and some of it's monologic. So you can have these standalone posts where people make a reasoned argument that are long, and then you have these rebuttal chains, which are very highly context dependent. So you start off with this data, you have the posts from both sides, you have a partial order in terms of time, because you can only get timestamps for Convince Me on the day. So if something's in a rebuttal chain, you can order it. You can order stuff by day, but within a day, you can't tell what the evolving context was on the web page at the moment when somebody did their post. So you're kind of missing a bit of the context. We do the same thing that Somasundran and Weeby did, is that we take discussions that are on what we would characterize as being the same topic, and we map them into a topic. So depending on the framing of the discussion, like these different discussions, different sides of the discussion would map to pro and con. So we go through a hand annotation procedure where we map those all into one big topic group, so we can have multiple discussions. And sometimes you have the same people showing up in different discussions, and sometimes you have different participants. So we get these related discussions merged to form topics, and those are our topics that we have in Convince Me, where we do have some of those playful topics like cats versus dogs, but then we have a lot of other social and political topics. And they vary a lot on how balanced they are. So if you look at marijuana legalization, almost everybody's for it in this particular case, in these particular discussions that we have. But then some of the other conversations are much more balanced, like climate change is more like 50-50. So the baselines that you get for stance classification are very different across topic. One of the first questions that we had when we started working on this data was, why is this problem so hard? So when we're looking at previous work, the accuracies that people were getting averaged about 64% over different topics, with best performance about 70% and the lowest at about 60% usually. And so we're first looking at this and we're thinking, why is this, why are the accuracies, none of the accuracies better than 70%? And so the first thing that we decided to do, especially when people had thrown a lot of feature engineering at it. So, you know, there's very, very creative kind of bootstrapping features by going out on the web, arguing features, opinion target pairs, all kinds of stuff going on. But we're still not getting, you know, super performance. So our first question was with this, what would a person do if you treat these posts as out of context posts, which is what most of the previous work was doing for stance classification. It wasn't taking the dialogue context into account or anything about the thread or the chain. We thought, well, what would people do? So the first thing we did was a study where we put stuff out and did stance classification on mechanical Turk. And we thought this was a pretty interesting result, that the overall human top line, overall human accuracy is only about 78% on this task. So then if you're saying, well, the human top line is only 78%, it's not very surprising that the automated methods can't get better than 70%. And so that was one of our first contributions. And then the other thing that I think is kind of even more interesting is that if you look at whether a post is a rebuttal or not a rebuttal post in Convince Me, it's much harder for humans to classify the rebuttal posts, the ones that have the contextual information and that are part of a thread. So the accuracy for non-rebuttals is 87%, and the accuracy for rebuttals is only 73%. So there's a huge difference between these standalone posts and the other ones. Which I think speaks also to the convoke corpus, because when somebody stands up and gives a speech in Congress, they're not necessarily really responding to somebody else. They've just been waiting for their turn, and they're making their big speech. You know, they're making their argument, and it's pretty much standalone. It's not really dialogic like this. And we also had conversations that were what we would call ideological, like social and political topics versus topics like cats versus dogs. And usually with some of these topics or Firefox versus Internet Explorer, people say what they have to say and they're not so deeply invested in the topic, and you don't get these long chains of rebuttals, and you don't get people getting, you know, hot-headed and stuff in the same way as you do for the ideological topics. So it's actually, the ideological topics are much more context dependent. They're much harder to interpret in this out-of-the-blue context. So those are kind of interesting findings, that you actually really need some kind of context in order to understand a big percentage of these posts. So for a specific example like this, like studies have shown that using the death penalty saves 4 to 13 lives per execution. That alone makes killing murderers worthwhile. So for that post, what side do you think somebody's on? It's out of the blue. Yeah. So it has very specific lexical cues. It's really easy to tell that this person is, you know, definitely for the death penalty. And similarly for this one, you know, if you say death is wrong, why should we take the life of another person? There's a chance that somebody's not guilty. So that post also, you can easily tell that, you know, this person is against the death penalty, even in the out-of-the-blue context. But how about this one? They're disagreeing, but with what? So if you look at that, that's your evidence. This is a hostile response, so it's a disagreement to this prior post, right? So you start to get a little bit of context. And that post is made by this same author who's pro-death penalty. So when you start to get this relational information, you can figure out that that person's hostile to that and that person's pro-death penalty. And so even though you don't have the lexical information in the post, you can actually start to figure out what side somebody's on. So this is, this is what we're trying to do in this algorithm that I'm going to present that we did for stance classification. And this is a kind of standard algorithm, a graphical algorithm, max cut, where it allows us to take some of this contextual information into account. So the basic idea is that we use this reply structure, which, as I said, the graph's not highly connected because you do have these standalone posts, but you have things in rebuttal chains. But what we do have is we have same author and response links. And so we build a graph, we use the text to determine the stance of the individual posts, and then we use those stance labels to figure out, once we've built the graph and we've partitioned it, figure out whether this side is pro and that side is con, or the other way around. So I just want to mention again that the replies in convince me are always rebuttals. So we just have these disagreement links in convince me. We don't have, like in our 4 forms data, where we just have a simple reply structure and it doesn't have any kind of label on it. So when we build the graph, the nodes represent posts instead of speakers in this particular case. So we're just using the post information. The edges represent relations between posts, so we have that there is a direct response, that it's a shared author, or that there's a history of interactions between these authors, which can also have some weight. So you might not have had, in this particular post, might not have been linked, but there could have been previous interactions between 2 authors. And then you can make your edge weights be either positive or negative. And what you want to do is that you want to, positive edge weights reward the algorithm for cutting the edge. So you encourage the algorithm to declare that the connected nodes are on opposite sides of the graph, or the negative edge weights punish the algorithm for cutting the edge. Right? So you just put your weights on your edges. We had a particular instantiation of this that was kind of out of the hat. We didn't have any way of estimating like what those weights should be. So we just had a particular instantiation, and this is what the graph would look like, where the green links in the graph are the same author links, and the black arrows are the direct responses, and the dotted lines are like that there's a history of the author-author interaction, maybe not in those particular posts, but in other cases. And what max cut does is it finds a way to partition that graph that gets the biggest score. So it just makes two stance groups. And when we had funding for this from IARPA, there seemed to be a very strong feeling that there must be multiple stance groups. But some of the sites explicitly encourage people to be on one side or the other, and even in the other sites where we have tried with annotation exercises to find evidence of multiple stance groups, like people staking out some kind of middle position, what our data shows is that those are kind of rare, that you tend to more get these polarized discussions where people are either clearly on one side or the other. Anyway, so for the stance classification, this is just supervised learning, where we have a whole lot of different features. I think we used JRIP, William Cohen's Ripper, for this. And it builds it induces a set of cascading rules for stance classification, and we had lots of different features in there that were based on prior work on sentiment analysis, dependencies, generalized opinion dependencies, part of speech dependencies, LIWC, and some representations of the context and discourse cues. So we threw a lot of features at that point in time. We've done lots more feature engineering, still a pretty hard problem. Anyway, these are our best results so far. So like I said, the random classification accuracy varies a lot across posts. So you start off with this distribution that goes between 50 and 78% for Firefox versus IE. The supervised classifier by itself does not do very well. The baseline classifier is really weak, just in this out-of-the-blue context, trying to classify by stance, which corresponds with the results that we had, what we saw in prior work. And in particular, in some cases, it actually does worse than majority class. So there's lots and lots of noise in this data supervised classifier. But when we put in this contextual information in terms of the collective classification, we get some huge performance improvements. As you can see, we can go from 61% accuracy in F measure 0.55 with the supervised classifier to 80% accuracy in F measure 0.78 there in the top row for cats versus dogs. And in the cases, so in all of these, we get really big, huge increases. And in the cases like this, the red lines that are underlined where we have these massive decreases in performance, those are because we're orienting the graph the wrong way after we get the partition. So the baseline classifier is weak, and sometimes if we just take a mean over all the baseline classifier, we end up we orient the graph the wrong way. And so if we had an oracle about how to orient the graph, our improvements would be even bigger. But even with those errors across all these topics, on average, we do massively better with the collective classification than we do with the supervised classifier. So that's a pretty good result, and we've been trying to beat this result for 2 years, and we haven't been able to. So I was telling some people at lunch we're using Lisa Gator's probabilistic soft logic. We have this big network, we have ideology in there, we have all this other stuff. We haven't been able to, and we've thrown lots of other features at the baseline classifier, and we haven't yet been able to beat these results. So the data's there, go and get it. See what you can do with it. So the open problems there that we're working on with stance classification is, a better automatic orientation of the partition components, but we don't think we can do that unless we can get the baseline stance classifier to be better. And like I said, we've tried a bunch, we've had commitment features, specialized opinion target pairs, lots of different kinds of feature engineering, and which will help with some topics, but if you're looking over this whole range of topics, we can't find features that uniformly improve things. And one of the open problems was, as I said, this stuff comes kind of pre-labeled by one of the affordances of the sites for the disagreement. So that's a weakness of this work, is that we kind of have this pre-labeled thing that, that some of these reply links are obviously rebuttals. So the next thing that I want to talk about is work on automatic recognition of disagreement, which would kind of fill in that. So we did have, in that convince me data, we did have recognition of rebuttal status, but we didn't actually use it. We had automatic recognition, but we didn't actually use it when we tested this collective classification algorithm. So, any questions about the stance? Okay, where's your clickers? Yes.
Was maximum fun? Do you have to worry about overfitting at all? Or is that a word?
No, you could. Yes, you could overfit, but you do end up. I think the biggest weakness for it is that that we don't have a way of figuring out what the weights should be on the edges. That you just kind of feel like you're like, oh, this is reasonable. Let's see what it does, and also that it just does a partition into two. So if you try to use algorithms that partition into more, then they suddenly they go away and they never come back. No, we haven't yet, but that Burfoot et al. Paper on the combo corpus uses 3 or 4 different collective classification algorithms, and they show Markov mean field something. I can't remember the details, but they show that does better on the combo corpus. But our data is so different that it's just not clear at all whether that would generalize. Yeah?
It seems that what you're trying to predict is which side or on a particular paragraph or argument is on, but do you incorporate that information in your step 1 where you're building the graph and you have that labeled?
We just have we have the rebuttal links. We just have it there was a direct response between those two people.
But you don't have the labels of which side or.
No, that's what we're trying to, we don't have that. And so we have that there's a direct response link, we know the same author. The other way to structure the graph is that you put all the posts, but you treat the nodes would be authors. And, but then which is what they do with Convo. But then you end up with this in our data, you end up with this very, very highly connected graph, and the problem of assigning the edge weights is even worse. So in our data, we felt like it was better to just treat the individual posts as the nodes. The experiments that we've been doing with probabilistic soft logic actually have put stuff together at the author level. And maybe that's why we haven't yet, I don't know. You know how it is. So we had an ACL paper where we show that we have a model that integrates stuff in probabilistic soft logic, but the results, the baseline results are not better than these. Okay, so any other questions? I'm going to talk about disagreement. Somebody might have to kind of tell me what time it is and stuff, because this is the first time I've given this talk and I'm not really sure how the time is going to go. So just to remind you, we have these mechanical Turk annotations for agreement on the 4 forms data on the quote responses and the post 1, post 2, post 3 links. And those are just reply links where you wouldn't normally, you don't know whether people agree or disagree. And the amount of agreement, as I said, like with these different topics, people are more or less invested. There's lots of different stuff going on. So if you just look at the amount of agreement across these different topics, you might get a lot of agreement for a topic like death penalty, and not very much agreement at all between posts for a topic like abortion. So maybe you can tell something about how polarized people are by the percentage of agreement across topic. But anyway, it varies a lot. In the experiment that we reported in our language and social media paper, we treated agreement and disagreement for forums as a binary classification problem, and we threw out the middle set of the data. So agreement was labeled on a scale of -5 to 5, like many of our other annotations that we have, and we just took everything that was by 7 annotators. So we take the means, we take everything that's between -1 and 1, and we just threw it out, and then we did classification on the posts that were left. And then my student, Rob Abbott, who did this work, didn't like the fact that the original corpus was selected to bias distribution of keywords to be 50% of the posts started with the keywords, because that seemed like that wasn't the original distribution. So then he further downsampled the data so that the distribution of keywords in the data that we tested was the same as in the original corpus, which meant we threw away, in this particular case, we threw away a lot of data. But again, we put a lot of different features in. We have discourse cues, dependency features, part of speech dependencies, opinion, generalized dependencies, using MPQA lexicon to get these generalized dependencies. We had textual similarity, loop counts, and as not really a feature, but as something kind of looking towards the future, we also have some experiments where we put in these extra annotations, like whether somebody's being sarcastic or nasty or nice or things like that. So our results in that work on disagreement, we had a balanced data set, so we get a random baseline. And in this particular case, it's pretty interesting well, first of all, I think it's interesting that there's such a huge difference in the performance of naive Bayes versus Ripper. So just generally, naive Bayes can't seem to do anything with this. It gets overwhelmed by too many features or something. And but some interesting things about this data is that just the unigrams from the response, which we would consider to be a reasonable baseline, is 64% accuracy. And if you just have unigrams and you add in the quote and features for both the quote and the response, so you have some kind of rudimentary representation of context, you don't do any better. Another thing that I think is interesting is that the quote by itself seems to have some signal, so you can beat the baseline statistically just by using the quote without even looking at the response at all, which is what was labeled as being a disagreement. And if you take the response local and you add in these extra features, you do get an improvement, that 0.666, but it's not statistically better than 0.64. So when you just have the response and you add in these extra features, you don't do better than just the unigrams. But when you have both the response and quote with this kind of rudimentary representation of context, where you basically double your feature vector and just represent the quote features as being quote features and the response as being response, we get this better performance when we have kind of higher order, more interesting features that are like lexical categories or opinion dependency features. So that's our best fully automatic result. And then, as I said, we have these annotations for sarcasm, nice, nasty, attack, insult, fact, emotion. So we experimented with like thinking, is it worth having a cascaded classifier where we first classify utterance as being either nasty or nice or whatever, and then feed those in. So this is like the best you could possibly do, it would seem, if you had those annotations. And interestingly, you get this massive increase in performance if you put those annotations in. And it's kind of it's not completely clear why the annotations would help so much, but they did, right? So that's kind of, in the current experiments that we're doing, I'm going to talk subsequent to this about some experiments we're doing on automatically recognizing things like sarcasm and nastiness, which would then give you the computational input so that you could see how you could do with the computational version of those. But in the current experiments, we're not downsampling the data at all. So we're just, because other people are doing this with our data. So we're not trying to be squeaky clean about the keyword distribution, and we're doing experiments where we're just throwing everything in, and in fact, we're kind of supplementing this with more data. And in this case, so we have the 10,000 QR instances. If you just take the data the way it is, 62% of them are disagreement, 11% are agreement, and if we keep the neutral class, which are those ones that we threw out before, there's actually 2,700 instances in the neutral class. And we use the same features that we did before. These experiments that we've done, we're using logistic regression, and we're trying to just run a bunch of experiments to basically, at this point, explore the effect of the data set size on the utility of different features. And, hello? Yeah?
So, I think the task was to predict whether the current user agrees with the previous user's post, right?
Whether the reply post agrees or disagrees.
So, are there any pairwise features, or is it just the features from the reply or the post?
In this case, in which case? Here?
This one.
Okay, our best performance has posts from features from the parent post and the response post.
So are they distinguished in any way, or it's just
Yeah.
Okay.
So like imagine that the quote features names all start with Q, and the response features names all start with R.
Oh,
Okay?
yeah, thanks.
So we just, yeah, that's what we did, which is, like I said, is kind of a very rudimentary representation of context. So that's our best result, right? With the 6.82, our best fully automatic result, and then we have this kind of interesting tantalizing thing that if we could recognize some of these social emotional categories, maybe we could do a whole lot better. So anyway, with this, we're looking at the data set size, and I think it's just interesting just for the data set. So I have different graphs for looking at disagreement, neutral, and agreement, and there's a couple of things that I think are interesting in here. The most interesting thing is that some features only start to be helpful after you get to a certain number of cases, right? And because I haven't seen anything like this in anybody else's work, it's been kind of completely unclear. it's kind of clear that unigrams by themselves aren't going to get you there. We've done lots and lots of feature engineering. What we haven't had before is the ability to kind of look at all these different features in the context of increasing the data set size by a lot. And you can see that, our performance is kind of still going up. And that blue line at the top, again, is with the annotations. So what's interesting is that, again, still as before, the annotations perform really well from the beginning. They seem to be independent of the data set size. So what you might think is that some of these features that are more sophisticated are starting to kind of build a model of maybe what's being annotated with those sarcasm and things like that, and starting to find features that kind of correlate with sarcasm or those things that you have in the annotations. And so the annotations, you get this almost, whatever it is, 79% performance without having a big data set size. But to start to get close to it with the automatic features, you have to get out there and start to have a lot more examples. So we're starting to approach those. On the agreement, the annotations actually help more. So even with more data, although since agreement is the small set, we don't, even though we have the same size, this is plotted on the same scale as the previous graph, we don't actually have as many examples of agreement in there, but the annotations are still kind of way above. But we are still seeing, we're still seeing some improvements as the data size goes up. Be interesting to see what would happen if we had 10 times as many agreements as we do now. What we found in our previous work, also in the Meisler and Walker work, is that you can very quickly find a bunch of features, n-grams, that are pretty good cues for disagreement, but it's almost impossible to find lexical features that are good cues for agreement. And then finally, interestingly, for the F-neutral case, where we actually have 2,700 examples, the annotations aren't helping. We can do as well with the automatic features for predicting the neutral, and I have no idea why. This is something that we need to do a lot more analysis of, is what it is about this neutral category that make it so that the annotations don't get us anywhere. But again, with the dependency features, this is something like we're frustrated. We're doing these opinion target pairs, we're doing all this sophisticated processing, we're doing scope of negation, we're doing verbs of speaking and suggest versus state versus claim, and all that. We're doing all this stuff. We can't get any improvement with all these more sophisticated features, and it's starting to look like now that maybe the reason we didn't get any improvement with those features is we didn't have enough data. So 30,000 examples was maybe like not enough. But we don't know because we don't have the 50,000 or 60,000 examples yet. So one other final thing from that is that we kind of want to, that those results suggest that it'd be interesting to predict the human annotations, maybe for the disagreement classification for sure, maybe independently, kind of in their own right, there could be interesting categories to predict. So we've done some work on, so far we've just done work on sarcasm and nastiness. We haven't done, this data's been sitting there. Nobody's done any work yet on factual versus emotional, which is kind of subjective. This attacking, whether you're directly attacking the other person or you're making your own independent argument. So there's annotations there that haven't been used by anybody yet to do any experiments that you could be interested in. We've done work, like I said, so far on sarcasm and niceness versus nastiness, and I'm just going to briefly kind of talk about some work that was done by a postdoc from University of the Basque Country who spent 6 months in my lab last year, Raquel Justo, and we've been working for several years on a bootstrapping approach to sarcasm detection, and we had weak results. And so I said to Raquel, well, actually, we tried this other approach. We haven't tried supervised learning. We don't have any baselines for supervised learning. We don't know what happens with the supervised learning. And so she decided to go ahead and work on sarcasm and nastiness, is what we've been trying kind of a weekly supervised approach for. And Another thing that we've done in the meantime too is we've done a reliability study for sarcasm annotation, because we noticed that the reliability for sarcasm, the kappa scores are much lower than for our other categories, and so we wondered what was going on there, whether some people just don't get it, or it requires a certain kind of verbal subtlety to recognize sarcasm, that other things are more obvious, or exactly what was going on. In our data, based on the reliability study, which I'll kind of show you briefly later, one of the things that's interesting is, well, we have things that are very, very clearly sarcastic that can be easily recognized as being sarcastic almost just on the basis of lexical cues, and then obviously we have cases where it requires more context or more kind of situational knowledge. So sarcasm is not a unitary phenomena. It can be very context dependent, but there are cases where there are really clear lexical cues for sarcasm. We might have actually better agreement that things aren't sarcastic than whether they are or you're not sure. And one of the things that we found in our reliability study is that it appears that sarcasm, like indirect speech acts, gives people the opportunity to deliberately be ambiguous about their intention. And so this particular utterance, after 30 annotations, we still have like a 50-50 split between annotators as to whether that utterance is sarcastic or not. And so maybe if you actually knew the speaker, you would be able to tell. But the thing about speech in general is that it seems to me that sarcasm is one of those cases where you can mask your sarcasm when you choose, and somebody who knows you well might be able to tell that you're being sarcastic, and somebody else standing there in the same space wouldn't. And that's something that we have in our data. So what we've done in these studies is we've taken any item in the corpus where at least 2 of the annotators said it was sarcastic, 2 out of 7 annotators. That's not majority class. We based that on like eyeballing the data. We kind of sorted it in different ways. We eyeballed the data, and our conclusion was many of the cases where only 1 person said it was sarcastic were sarcastic, so there's some kind of verbal subtlety or something that, some people don't recognize it. Whenever at least 2 people out of 7 said it was sarcastic, it seemed to us it's clearly sarcastic. And so those are the cases that we've used in this particular experiment. And Raquel did a massive amount of feature engineering with this, and the best result that we're getting, this is over 50% baseline on a balanced corpus, is we're getting a 70%, an F measure of 70. And this involves using, we have some cues that we were using in our bootstrapping work where we put a task out on Mechanical Turk and told them that other Turkers had said this utterance was sarcastic. Even if they didn't think it was sarcastic, would they pick out anything in the utterance that they thought was a cue to sarcasm? So we found that we had this actually highly reliable annotation for people picking out the cues to sarcasm. So we had these cues we were using for bootstrapping, and those by themselves, just those cues, you get 66 F measure without anything else. But when you start adding in these statistical features that are just fully automatic, when you have the big corpus, you do better with those. And I don't think that difference between 70% and 70.6 is significant. So these Mechanical Turk cues help when you just have a small amount of data and you're trying to find some kind of lexical cues. But if you just have a massive amount of data and you just throw the kitchen sink at it, you can do a lot better. And the other thing that we discovered was that this nastiness detection is much, much easier than detecting sarcasm, which isn't really very surprising, but it's kind of nice at least to have a confirmation of your basic beliefs. And so the last thing I just want to briefly show is this reliability study that we did that we reported at LREC this year. So we had these pre-existing annotations for sarcasm, and we collected another 25 annotations, and we had stuff classified as it came in on the basis of the previous annotations as to whether it was sarcastic or not. So the blue ones are sarcastic, the red ones are definitely not sarcastic, and the white ones are ones that we would have said were in the middle category, that we kind of weren't sure on the basis of our annotations. And so what you can see as you go over here is that some of them settle down very, very quickly. So basically, on the basis of like 3 annotations, in some cases, you can say whether it's sarcastic or not. So if you get total agreement with 3 annotations for sarcasm, it's sarcastic. And having 25 annotations, nothing changes. Also, for the ones that aren't sarcastic, you see all these red ones down here. It's very rarely the case that they actually completely flip category from 3 annotations. So we wanted to know whether, this was the kind of problem that, unlike all the other mechanical Turk language problems where people are saying, 7 annotators is definitely enough, you get expert performance, or 9 annotators or whatever for these different kinds of problems that people have done, we thought, well, maybe, the fact that we've got this very low kappa shows that for sarcasm you actually need a lot more, but it actually doesn't look that way. So by the time you get 9 annotators, nothing flips category anymore. So that was useful to suggest that we can kind of supplement our annotations for sarcasm with 4 or 5 extra annotations for the cases where we are in the ambiguous area and that we don't actually have to go out and get 20 or 30 annotations to have reliable annotation for sarcasm. Okay, so that's finished. I just tried to convince you that there are lots of really interesting open research problems in the online dialogue. I showed some of our results for collective classification for stance, disagreement versus agreement detection, and the sarcasm detection. And I'm happy to take any more questions, including like, what's the surf like today in Santa Cruz? Yeah?
So thanks for this great survey of a really interesting problem space. I didn't know very much about this. It strikes me though that, so you mentioned briefly that you've been doing some work on bootstrapping in this area, and it really strikes me that, we can't annotate this, we have trouble annotating this, it's expensive to annotate, but we have tons. We have more examples of conversations on the web that we know what to do with. So a semi-supervised learning approach does seem to be like, a really kind of nice thing. Could you briefly say sort of what that sort of line of research does it exist? How does it work?
Other people's research?
Yours or other people's, or I just don't know this area well.
I don't know. Jan, can you answer that question? Well, with our work, we were trying to use like a classic bootstrapping approach where you have some seeds that are very reliable, and then you generalize from those seeds, and you go back and forth. And we have had a lot of trouble finding the seeds, like for sarcasm. For nastiness, it worked really well. So our results actually, I'd have to go and check exactly, but I believe that our results for bootstrapping from 600 label utterances for nastiness are as good as what we get using the whole corpus for supervised learning. But for sarcasm, we didn't get anywhere close. And we had trouble, I'm still doing experiments in that area. I was concerned, the work that I was building on was some work by Ellen Ryloff and Jan Wiebe, and they had a high precision classifier for subjectivity, objectivity. Their initial high precision classifier was like 92% precision, and 92% precision and 32% recall. No, 32% recall. Anyway, they ended up with something that was 89% precision and 40% recall. So they got big recall improvement without losing precision. When we started doing these experiments using the same method, we couldn't get anywhere close to those kinds of numbers. So we couldn't find the seeds and for sarcasm. So we had these very reliable cues, but they were all kind of weak cues. Now I'm going back and looking at that thinking, well, maybe I would be happy with 12% recall. So I was trying to not have start with such horribly low recall as like 10 or 12% recall in order to get maybe 80% precision to start with. And that's still like way lower than what other people have when they've done this kind of task. So I think it's just for some of these problems, you can't get the initial seeds because the data is just too messy, it's dialogic, it has all this context, all this stuff going on.
All right, thanks.
Yeah.
Where is the data listed, or how easy is it to find that?
It's in my slides. If you go to if you search for NLDS software and downloads, you should be able to go in there. Or if you go and you look at our LREC 2012 paper that has the corpus paper, it has a link. So, and you can just download it, and it's not gated. We just ask for people's emails. So I'll ask you for your email, but it's not vetting you. It's just so we can keep track of our downloads. So you can go and get it. And if you have any questions, just write us. Yeah?
In the slide when you showed the labels, you have the six, you're looking for the sarcasm. You have the column of labels, yes, no, and yes.
Yeah?
For the mechanical term, yeah, this way. Are the readers being asked to read sarcasm on the parent sentences? On a like the assertion and rebuttal.
Yeah, exactly that same context. So they're just shown one parent post and the response, and they're asked to rate the whether the response is sarcastic.
So is there less confusion when the sarcasm is in real, the second phrase, than in the first one?
We don't ask them about sarcasm in the first one.
Okay.
We only just ask about the response, and we just provide the parent post. So it's either a post 1, post 2 pair, or a post 2, post 3 pair, or a quote and a response.
Okay. So you're going with the response.
Yeah, we just ask people for labels for the response. Which is why in that disagreement case, why the fact that the quote has signal for disagreement is kind of interesting, because we didn't ask people to label it. So what is it about a quote, a context, that is a better than baseline predictor for disagreement in the response? Yeah, I don't know. I think it's interesting. It's kind of not intuitive. So it's some kinds of things that people say breed disagreement, right? So did I answer?
You answered my question.
Okay, fine. Anybody else? Yes?
So throughout this talk, I've been trying to figure out whether what you're interested in is the task of solving stats classification, disagreement, or sarcasm, or if what you're really interested in is the linguistic indicators of those things. The linguistic indicators of how we know they're reading a text, independent of anything we might know in the context.
Aren't they the same thing?
I don't think the same thing, because I mean, if you cared about the task itself, not just the linguistic aspect of it, there's a lot of extra linguistic information you could be
There's
using.
what?
There's a lot of extra linguistic information you could be using. So in the stance classification, you're using information about the author. You're enforcing consistency among all the different posts that are by the same author to encourage them to be in the same stance on the same topic. You could use information about the author for sarcasm and for disagreement as well. I mean, with the assumption that there are just some people who are naturally more sarcastic.
Disagreeable.
Yeah,
Yeah.
you could.
Yeah, that's something that I forgot about, that we talked about before, about putting that in as a feature.
Okay. So you do care about that. You don't care about just linguistics, just linguistics.
No, I don't. I'm interested in the automatic classification. And what I think about the sarcasm is that I think that I don't think our features are kind of getting at the heart of it. So, so if you look at the literature, it's not very helpful, I'll say that. It's interesting that, there's like, according to like prior theoretical work, there's 5 or 6 kinds of sarcasm. So if you look at people that have worked on spontaneous dialogue, not like work that where people are using made-up examples, but people who have collected spontaneous dialogue and labeled it, there's lots of different kinds of sarcasm. But what everybody emphasizes is that you need to know a lot about the speaker, you need to have common ground, you need to be able to, and that's clearly true at some level, but if you look at a lot of our examples, you see that a lot of them, they just leap out at you that there can be nothing else but sarcasm. Some of them have lexical cues, and some of them I would characterize as this kind of what I would call a ridiculous situation. So if you say things, this, like our snails have been undercut, that's clearly kind of dramatic, our snails have been undercut. Another example would be somebody says something like, oh yeah, when I have a kid, I'll just leave it in the woods because I'm sure, it can take care of itself. So I think if you start looking, if you had a lot of data and you started trying to have more features that characterized, say, maybe attitudes or arguments, predicates applied to objects that they're not normally applied to, like leave a child in the woods. There could be even some kind of frequency that you just know that's a ridiculous situation. And then there's things, like people know culturally, like, if somebody says, oh yeah, the Spanish Inquisition, that was so tolerant, they were so tolerant, right? Everybody knows the Spanish Inquisition's not tolerant. So there's a whole lot of different classes of things, and each class might require a different kind of higher level feature. So in that sense, that's why I'm saying aren't they the same thing? In that sense, trying to understand something, like looking at the data and trying to understand what it is about it that signals sarcasm, from a linguistic or semantic perspective, I think is the only way that you're going to make progress on some of these kinds of problems. Yeah?
Have you guys looked at humor as well? Because some things that you just said, for example, where sarcasm could be detected by having these ridiculous situations, that's also used when generating humor.
We haven't looked at humor. I mean, most of the sarcastic examples I think are funny, but that could be because I'm a nasty person, I don't know. So we haven't looked at humor, but that would be, I don't know. Do you think that's funny?
It's trying to.
Do you know of anybody that's worked on humor in social media?
I think there's some, yes.
Huh? In Twitter? Is there a hash funny?
There are many papers, I don't know though.
Maybe not just Twitter, but definitely.
It's sad if you have to mark it that way. Aha, yeah. Aha, hash funny. Okay, we done? Class dismissed, right?